All right, so this next section, just so that you guys know, is very similar to what we've been doing the last 2 days with arithmetic. This time, though, we're going to be a little bit different. We're going to look at it not adding and subtracting, but, right, multiplying and dividing. So these are called geometric sequences. Okay? So when we're adding and subtracting, we're arithmetic. When we're multiplying and dividing, we're geometric. So when you are identifying them, that's the difference. If you add or subtract, you're arithmetic. If you're multiplying or dividing, you're geometric. If you're not doing any of those, then you're your own sequence, like if you're squaring or whatnot. So for this one, what you're going to do is I'm going to give you a pattern, and I want you to tell me if it's arithmetic or geometric or not. Am I multiplying or dividing this by the same number every time in order to make the next one? What would I multiply 6 by to give me 12? 2. So timesing it by 2. If I times this by 2, does it equal 20? No. So is this geometric? No, it's not, because it's not multiplying by the same number every time. Okay, the next one. If I give you a 256, 64, 16, 4, 1, blah, 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 is that multiplying or dividing by the same number every time? Okay, I am dividing by 4 every time. 256 divided by 4 is 64. 64 divided by 4 is 16. Divided by 4, you bet. Okay? So for this one, the answer would be yes. Why? You're dividing by 4. Now, when we do that, we don't say divide by 4, though. Here's the difference with this one. We don't say divide by 4, we say multiply by a fourth. Okay? We're going to multiply by a fourth, because when we get to the generic formula, we're actually going to put it in there as a fourth rather than a divide. Okay? So whether you multiply or divide, it has to be by the same number every time. That is called the common ratio. Okay? The common ratio this time. Instead of the common difference like we did with adding and subtracting, this one's going to be a common ratio. So again, even though you guys identified that we're dividing by 4, it's really multiplying by a fourth. And now the reason for that is because of this generic formula that, like what we had for the first one. A sub n equals A1, R, you go into them all later, n minus 1. What's the little dot mean? Right. What's A1 besides steak sauce? Never gets old. Your mom. First term. And the R stands for the common ratio. So for the first one that we just, or the last one that we just did, the common ratio, or the R, would be 1/4. You can't say dividing by a 4 in here because it just won't work with the way the formula is written. That's why when we say divide by 4, we're actually saying multiply by a fourth. Same thing, but just a little bit different way in the notation. Okay? So, on something like this, if I gave you 5, 15, 45, 135, I want you guys to tell me what the rule is. So first of all, what's the first term? What? 5, right. 5, nit, n minus 1. What's the ratio? Multiplying by 3, so that's the R. Now, I'm not going to put the multiply symbol in there because what's the parentheses indicate? Multiply. Right. Done. That's the rule. Very similar to the addition one or the arithmetic one where you put A1 in and you put the D in. And then you were done. Now from here, I'm going to actually ask you for what's a sub 7, which means I want the 7th number. Now, one of two ways of doing it. You can continue multiplying by 3 till you get 7 of them, or you can put 3 or 7 into the formula and see what you get. 5 times 3, 7 minus 1. What's 7 minus 1? So 5 times 3 to the 6th. What's 5 times 3 to the 6th? Okay, 3,645. Awesome. Okay? Now, I want to point this out to you guys for this first assignment. Does this look familiar to what we did with the arithmetic ones?
Yeah.
They're, except for multiplying and dividing, we're doing the same properties. The only thing it's not going to do for you, if you notice that I only gave you a sub 7, do you remember on the arithmetic ones we had a sub 20? The reason why it's not going to give you the bigger numbers for that is imagine putting 20 in for the exponent. 20 minus 1 is 19. You'd have 3 to the 19th power. That's pretty big. Okay, so they're not going to give you as big as they did for arithmetic ones. They're going to give you a smaller number to put in, but it's the same process. What do you think? Good. 88, negative 44, 22, negative 11, bop, bop, bop. I want the rule first. So, what's A1? Okay, hold on. What's A1? 88. All right, now, the question from Amanda came was, am I multiplying it by 2 or multiplying, or what did you say? Dividing it by 2? Okay, we got a negative also in there, but remember when we said how we're going to write divide. Okay, we're going to multiply it by a half, but the signs are alternating. So when it's like that, we do have to have a negative involved. Now, here's one little trick. To finding that ratio, in case you're not sure about how it goes, here's the trick with it. To finding the ratio, take the second term divided by the first term. That's as easy as it can be. What's the second term in this sequence? Divided by 88. Which when you reduce negative 44 over 88, you get negative 1/2. Okay? That's how you find the ratio if you're given a sequence like that. Now another thing that you can do is, I just took the second divided by the first. What if you don't have that? What if you've got like the 10th one and the 9th one? Could you do it there too? Yeah. As long as you have consecutive terms, you could do it anywhere. Okay? So negative 1/2 is going in there. Now the next part is, I want to know what the 7th term is. 88, negative 1/2, 7 minus 1. What's 7 minus 1? 6. Now, you guys can use your calculators to type that in. What do you get? Fracket. Is it a positive or a negative? Positive. Do you know why? The exponent is an even number. So then it would be a positive. Good. More accurate. Depends. Not for this one because the decimal would come out evenly. But if it's ones that would have been like 1/3 and you just put 0.3, that's not the same as 0.3 you're repeating. Okay, what do you guys think of those? Not too bad? Okay. Last type that you're going to see today is going to be something like this, where it says a sub 4 equals 12, and the r you going to them all later is 2. I want to know the rule. So again, looking back to what we did in section 2, at the beginning of section 2, day 1? Isn't this the same type of format? Remember where I gave you a term and then I said, here's the D? Okay, this time I'm saying, here's a term, now here's the R. Let's work backwards to find the formula. So, do you know A1? No, that's what you're going to find. What's your R? 2. What number did you insert? Not the 12.
4.
You put in the 4 to get out 12. Okay? So the 12 is going to go in the AN slot, and the 4 is going to go in the N position. So now to work backwards to find A1, this is how they're going to act. What's 4 minus 1? What's 2 to the 3rd power? Good. Glad you didn't say 6. So I have A1 times 8. How do you get rid of times? Divide by 8. What's 12 divided by 8? 3/2? Oh yeah, I was thinking it was different numbers. Never mind. Yeah, you were right the first time, Amanda. So A1 equals 3/2. So my rule, 3/2, 2, and minus 1. What if it asked you to graph the first 6 terms, just like it did on the arithmetic ones? Then you make dots. You put 1, 2, 3, 4, 5, 6 in and see what you get and make dots out of them, right? So what do you guys think? Yes? Maybe? Not a clue? Good?
4 300 and 4 300. Honestly, I didn't either.
Yeah, like 1, 2 goes in where N is. Yep.
And then Jensen's like, this is the thing I'm never gonna do. This is our response.
Alright, so here's what you got then on page 430.
Like
6 to 30 multiples of 3.
between each 300, we only got a 2-minute class. So it's like, what is distance? Yeah, but